right, beautiful students of mine. We're on part 9, number 54. We are slowly getting through all of it. All right, if I can do it, you can do it. Well, actually, I take that back. You can do it, so do it. There, that's much better. All right, so we've got sequences in series. 1 plus 1 plus 2 plus 3 plus 5 plus 8. Hey, I know this one. All right, and it says, state whether the following problems are sequences or series. Then, classify them as arithmetic, geometric, or neither. If the sequences or series are arithmetic or geometric, create a general rule for them and find the sum of the first 15 terms. That is so much crap to do. Alright, so let's just go ahead and do it all in that order on each of these problems. Luckily for us, this is the Fibonacci sequence, and it is not arithmetic or geometric. So an arithmetic sequence would be one that you add the same number every time to get the next number. So 1 plus 0 is 1, but 1 plus 0 is not 2, so it cannot be arithmetic. Geometric is where you multiply by the same number to get the next term every time. So to get from 1 to 1, you have to multiply by 1. If you multiply by 1, you don't get 2, so it can't be geometric. So it's got to be none. So this would be neither. And then you want a happy face because you don't have to do any more work. Alright, so number 55. And by you don't have to do any more work, I mean we don't have to do any more work because I am also doing all of the problems I assign you guys. Except I'm also doing all of this extra crap, just so you all know. Alright, so the next one is 2 plus 4 plus, actually, this reminds me, 6 plus 8 plus 10 plus da da da. The first thing says state whether the following problems are sequences or series. Both of these are series. Yeah, they're those things. And the reason I can tell that is because there's plus signs. If there's plus signs, right? Plus signs mean series. So that's plus, 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 plus. All these pluses means we're dealing with a series. If there are a bunch of commas, we'd be dealing with a sequence, right? So it's a series. And now we got to figure out, is it arithmetic, geometric, or neither? So if you look here, the difference between each of these is 2. If you look here, you add 2, add 2, add 2, add 2. That is now a 2, right? So since you're adding the same thing every time, this is arithmetic. And we say that the common difference is 2, the value you're adding every time. We'll need this in order to create the general rule for the sequence or the series. So the general rule, we just had a test over this, the general rule for arithmetic sequences is a sub n equals a sub 1 plus n minus 1 times d. Right, so all you have to do is plug in a sub 1 and d. So that would mean that a sub n equals a sub 1, and that is the first term, which is 2. Alright, so a sub 1 is 2. So you get 2 plus n minus 1, that can stay n minus 1, times d, and d is 2. This is your general rule. I will accept this as a general rule. Then you need to find the sum of the first 15 terms. Well, the sum formula is that a colon or is that an exclamation mark? The world may never know. Alright, so for arithmetic is s sub n equals n over 2 times a sub 1 plus a sub n. Alright, that's an n. I'll just make that more clear. Alright, so in this case, right, n is the number of terms. That is so not the word terms. I don't even know what that was. The number of terms you are summing. Alright, I'll buy that, I guess. Alright, so a sub 1 is the first term, and a sub n is the last term you're summing. That's the key thing. That's the tricky part. So if we're going to try to find the sum, so we got the general rule, we're doing great. It says to sum the first 15 terms, so that means n needs to be 15 because that's the number of terms you're summing. So s sub 15 is 15 over 2 times the first term, which is 2, plus the last term you're summing, aka a sub 15. A sub n, that's your n, that's your n. You plugged in 15 for it. So what we don't know is a sub 15, and that is the 15th term of this sequence. And it happens to be a series, so excuse me. So to do that, you use the general rule. Plug 15 into the general rule. So you're going to get 2 plus 14 times 2, which is 2 plus 28, which is 30. I'll do my best to multiply these out, but I'm not making any promises. I might just eventually just leave them since I don't have a calculator here. I should have brought it, but, you know. What can you do? I'm not going to drive up to school to get it. So, you've got 7.5 times 32. So, 7 times 3 is 21. So that's 210, and then 2... 14 or 224, and then I'm just whatever. Let's just write whatever that equals. Alright, so that's it. Moving on. Number 56. Negative 1, positive 2, negative 4, positive 8. You're not a positive 8. Go back. Good. Negative 16, dot, dot, dot. Now notice, in this time we've got a bunch of commas, comma, 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 comma. That is an indicator of a sequence. So that's sequence. Next, we need to verify, is it arithmetic, geometric, or neither? So, first off, definitely not arithmetic. It's going from negative to positive to negative to positive to negative to positive, right? Not arithmetic. But if you notice, there's a very common looking thing here. Multiply by negative 2. Multiply by negative 2. Multiply by negative 2. Multiply by negative 2. This means that it is geometric. Geometric. And the common ratio is negative 2. The common ratio is the value you are multiplying by. Something to point out. If you are subtracting up here, you can't say that the common difference is the value you are subtracting every time. The common difference is defined as the value you get when you take a term minus the previous term, which is also known as the value you add every time. It has to be add. It cannot be subtract. So if the common difference up here happened to be negative 2, or if you were subtracting every time to get the next term, then the common difference would be negative 2, not a positive 2. You can't rationalize it thinking to yourself, well, this is what I subtracted, so it's going to be 2. Right? So up here, this is typically seen when we're talking about dividing. So if we were dividing by negative 2, people would say that it's still negative 2, even though it's not, because that's not what you're multiplying by to get the next term. Anyway, we might get to that. So now that I think about it, this is going to start to these problems are getting harder and harder to do without a calculator, but I might pull my calculator up on my computer if I have to. All right, so The formula, all right, scroll back up here. The general rule formula for geometrics. Yeah, my E tried to turn into an O, and it did successfully. My geometric formula is A sub n equals A sub 1 times R raised to the n minus 1 power. And your sum, this is always hard for me to remember, is S sub n equals A sub 1 times 1 minus R to the n over 1 minus R. That looks right. Alright, so knowing this general rule up here, your general rule is A sub n equals the first term, which is negative 1, times R, which is negative 2. Don't forget to put this in parentheses. Raised to the raised to the n minus 1 power. Alright, there you have it, your general rule. Now we need to sum the first 15 terms. Well, the sum formula, in this case, does not need A sub n. Right? There's no A sub n, so we don't need to find the 15th term. We just need to plug everything in. So it's going to be negative 1 times 1 minus like open parenthesis, negative 2, close parenthesis, to the n power, and that's 15, all over 1 minus negative 2. Yeah, I'm not even going to try to do that. All right, that's some number, and that'll be what we call it. All right, very good. Number 47, or 57. It's getting late. It's now 9 o'clock on a Friday. And while all of you guys are out having fun on a Friday, I am slaving over my computer desk writing this for you, just so you know. All right, so we've got 31. Why did I make this problem? I'm not going to. All right, 15.5. This is actually not so bad. 17.75 and 3.875. So I happen to know that 15.5 times 2 is 31. And then I know that 17 times 2, wait a second, this is supposed to be 7. Hey you're supposed to be a 7, not a 17. Alright, very good. I happen to know that 7 times 2 is 14, and 0.75 times 2 is 1.5. And 14 plus 1.5 is 15.5. Then the same thing I think is true here. You know what? Just give me just 1 second and I'll find out for sure. Pull out the old handy dandy calculator. You can't see this, but it's happening. Is 3.875 times 2? 7.75. Look at that. We have a winner chicken dinner. So what's happening, and the way I've been presenting this so far, is saying what you're multiplying as you go to the left by. That is not how you want to think about this. That is not what you want to think about. If you have to take this number and take the previous term, and multiply it by 2 to get the previous term, then what's happening is you are dividing by 2. And again, a common ratio is not what you are dividing by to get the next term. So this is geometric. But it's not because we are dividing by 2 each time. It is because you are multiplying by a half. You are halving it every time. That makes the common ratio a half. So, now the general rule, A sub n equals A sub 1 times R raised to the n minus 1 power. Well, A sub 1 is 31. R is a half n minus 1 power. Excellent. And the sum of the first 15 terms is the first term, 31, times 1 minus R, which is a half, to the 15th power, all over 1 minus R. Very good. Congratulations. Happy faces all around. All right, so we're done with that, and that I'll just say that equals a happy face. And if you disagree, then you're wrong, because I got happy when I saw this problem, so it has to be right. 58. All right, this is a, oh wait, we forgot to say that this is a sequence. Excellent. 58. Negative 52. Oh, I don't have a comma. Minus 44, minus 36, minus 28, plus dot dot dot. This is a tricky one. This is definitely a series. No comma, series. Now, let's compare. All right, so if you added 8, yeah, 8, then you'd be down to negative 44. So you go down 8, you add 8 again, so you'd be down to 40, and then, yep, that's right, and then add 8 again, 6 and then 2, yep, that's right. So you're adding 8 every time. When you're adding the same number, even, well, actually, even if you're subtracting, it's called an arithmetic sequence. All right, so it's arithmetic, first off, and the common difference is 8. You're adding 8, that's what you do. Right? And then the general rule is the first term plus n minus 1 times d, which is 8. So now the sum of the first 15 terms is n over 2, which is 15 over 2, times the first term plus the last term. That's what we don't know. So we need to figure out the 15th term. So we use this to do it. Oh boy. So 80 plus 32 is 102. Negative 52 plus 102 is what, 50? This is the general idea. I don't know if my math's exactly right, but whatever. So there you have it. There's your sum. Whatever that equals is your answer. All right, very good. The last problem, 59. 59. 1, 3, 7, 15. Ah, what a great last problem. You're thinking, man, I still have to do these dumb problems. This is a sequence. Okay. And then you add 2, which I'll write down. But then you add 4. Then you added 8. So it can't be arithmetic. Then you think, well, you multiplied by 3. Did I multiply by 3 again? No, I certainly didn't. So it's not geometric. So it is neither. Woo! That's a real happy face. All right, that marks the end of this part. The next part will be about rational functions. Everybody's favorite type of function. It's just the greatest. That's where we talk about Bobo Botten eating DC. However, you'll have to join me on the next one to hear about it. And thank you all for watching, and please make sure you keep up the review and keep working on it, and check out the solutions to the next ones. That was a terrible outro, but at this point, you're really in it for the long haul, so whatever.